topic of discussion now is insertion sort. In insertion sort, we're going to divide the dataset into two parts. The sorted part on the left and the unsorted part on the right. For visual indication, we're going to draw an yellow line separating the unsorted part and the sorted part. We are also going to use two variables, P and M, for short. P stands for the position where we may potentially insert the unsorted element at any given time, and M indicates the unsorted element we are trying to position at the right location in the sorted part of the dataset. So we're going to take one unsorted element and we're going to compare it against every element in the sorted part and see what is the appropriate location to insert that unsorted element. That is the core goal. Again, we're going to take an unsorted element and we're going to compare it against every element in the sorted part of the dataset, and we will determine the appropriate location to insert that unsorted element, and we'll repeat this step until there are no more unsorted elements left. Alright, let's start. So in front of you there is a data set of 4 elements, and as obviously they are marked by positions from 0 to 3. We draw an yellow line separating position 0 and 1. So initially only element 0 is the sorted part, and elements 1, 2 and 3 are part of the unsorted part. Well, we'll start with the first unsorted element, which is at position 1, which is 3. We're going to write it as element 3. We're going to set our M as 3, which is our unsorted element we're trying to position, and our position is 1 because that is where our unsorted element is. Alright, so we will be comparing our element at position 1, which is 3, with element at position 0, which is 4. Well, since 3 is less than 4, we're going to shift 4 to the right, which basically means we're going to copy 4 to position 1, which is essentially shifting 4 from position 0 to position 1. Alright, so now our orange line indicates where element 4 is copied to, which is position 1. So now we have 0 and 1 as 4, but there is nothing else our unsorted element 3 can be compared against because we are already at position 0. So all we're going to do is we're simply going to copy 3 to position 0. So that's what we're writing now. Those are the indexes, and as we see, 3 is in position 0 now, and element 4 is at position 1. So that looks like they are in the right position. And at this point, let's just write out P and M. Our P is 0, our M is 3 still, of course. So now our orange line indicates where M is copied to, which is position 0. That completes our iteration 1. Now we're going to move our yellow line to one position right, which is between positions 1 and 2, which basically means position 0 and 1 form our sorted set, so which is 3 and 4, and positions 2 and 3 form our unsorted part of the data set. Right, so that's our yellow line. Now our M, which is our first unsorted element, would be 12. And our P would be 2, which is the position where 12 is right now. So we're going to compare 12 with the first sorted element, which is at position 1, which is 4. And since 12 is not less than 4, we will not we will not shift 4, and we're going to copy 12 to whatever the position of P is, which is 2. So we basically didn't do anything with 12 because it's at the right position. It's greater than any element in the sorted set. So we're going to leave it as it is. We're going to copy 12 to position 2, which is its position anyway, but we wrote it so that you have it, so that you don't miss a step. All right, so we're going to show where 12 is copied to using our orange line, which is pointing to position 2, and that completes our next iteration. Now we will shift our yellow line to one position right, which is between position 2 and 3, which basically means elements at position 0, 1 and 2 form the sorted set, and the only element at position 3, which is 5, is the unsorted element, and we will try to find the right position to insert 5. So our P now will be where our element 5 is, which is position 3, and our M would be our unsorted element, which is 5. Now we're going to compare 5 with the first sorted element, which is 12, and since 5 is less than 12, we're going to shift our 12 to one position to the right, which basically means we're going to copy element 12 to position 3. So element 12 is at position 2 right now, and we're going to copy it to position 3, which is what our P is. So that leaves us with 3, 4, 12, and 12. All right. So our P would be now decremented because we'll be comparing P, we'll be comparing our unsorted element with the next element in our sorted set, which is element 4. So our P now decremented from 3 would be 2, and our M would be 5, which is always our unsorted element. And now we're going to compare our unsorted element M, which is 5, with element at position 1, which is 4. And since 5 is less than 4, it's false, it's not. So we're going to copy 5 to the position which is pointed by position P, which is 2. So as you notice, we're always comparing our unsorted element, which is in element M, with the element at position P minus 1. So when P is 2, we are comparing it with 1. When P is 3, we are comparing it with element at position 2. So keep that in mind when we write our code. We're always going to compare our unsorted element with whatever element is at position P minus 1. Because if it is, if our unsorted element is greater than the element at position P minus 1, we found the location where we want to insert our unsorted element, which is obviously P, because our unsorted element is greater than whatever the value is at position P minus 1. So now when we try to shift our yellow line to right, we reach the end of the array, and so our P would become 4, which doesn't make sense because we crossed the limits of the array and we got ourselves a result.